Hello everyone and welcome to one and all present in this class. My name is Ram Roshan Kumar and today I am going to teach you a very fundamental and important chapter of calculus named as a function. So in today's class, first of all, I will give you a brief introduction about Cartesian product and relation, and after that we will define the concept of function with the help of relation and Cartesian product. So now let's start with the Cartesian product. Suppose you have a two non-empty set x and y, and we want to define the Cartesian product from set x to y. So it is a very simple. First of all, you have need to write x cross y, and this is equal to the collection of all the ordered pair from set x to set y, such that first element of this ordered pair is comes from this non-empty set x, and second element of this ordered pair is comes from this non-empty set y, and this collection are called Cartesian product from set x to set y. Suppose x have a two element 7 and 8 and y have a three element 5, 4 and 2, and we want to find Cartesian product from set x to set y. So how to find? So it is a very simple. First of all, we have need to write these two non-empty set in the form of Venn diagram representation, and now we can choose any one element from set x because we want to write Cartesian product from set x to set y. That's why we have need to choose any one element from set x, and then we can join all the element of set y from set x, that is 7, 5, 7, 4, 7, 2, and you can also apply for all the remaining elements, and here only one remaining element, that is 8. So this is equal to 8, 5, 8, 4 and 8, 2, and after that we can write the ordered pair, and ordered pair is equal to 7, 5, 7, 4, 7, 2, 8, 5, 8, 4 and 8, 2, and collection of this ordered pair are called Cartesian product. Now let's move on another important concept, that is total number of subset. So for finding total number of subset, you can simply use this formula, that is 2 to the power n. So n is the total number of element present in any non-empty set, or n is the number of ordered pair. In this case, suppose we want to find the total number of subset for this Cartesian product. So here we have need to count total number of ordered pair, and you can see that here total 6 number of ordered pair. So what is the total number of subset for this Cartesian product? Total number of subset is equal to 2 to the power 6, that is equal to 64. So this is the concept of Cartesian product. I hope you understand very well. So now let's come to define the concept of relation with the help of this Cartesian product. Suppose you have a two non-empty set x and y, and if you find a Cartesian product from set x to set y, then all the possible subset of this Cartesian product is called a relation, or it is also known as a binary relation from x to y. Suppose r is equal to 7, 5, 7, 4, 8, 5 and 8, 2, and you can see that this is the subset of this Cartesian product x cross y, and phi is also a subset of this Cartesian product x cross y. So we can say that these two subsets are also a relation from set x to y, because according to the definition, all the subset of this Cartesian product is called relation. So for this Cartesian product, total 64 subset are possible. So all these subset are a relation from x to y. Now suppose that if we write this in the form of Venn diagram, and you can see here 7 is associated with 5 and 4, and you can also see here 8 is associated with 5 and 2. So basically this is a form a relation from set x to y, and you can also verify by using the definition of the relation, because this non-empty set is a subset of this Cartesian product. So this is a relation. We can also check for this r. So here r is the 7, 5, 7, 4, 8, 4 and 8, 2. And if you draw the Venn diagram for this non-empty set R, then 7 is related to two element 5 and 4, and here 8 is related to two element, that is 2 and 4. So this is also another relation on this non-empty set x and y. So this is all about the concept of Cartesian product and relation. Now let's move on our main topic, that is the function. So what is the function? Basically function is a special type of a relation. Suppose you have a relation R from set x to y such that each element of set x is uniquely associated with some or all the element of set y, then this type of relation are called function. Suppose we have a relation R and here 7 is related to 5 and 8 is related to 5. That means all the element of set x is uniquely associated with some element of y. That means we can say that this is a special type of relation. You can also verify for this relation R. It is a simple relation or a special type of a relation. So first of all, you have need to draw the Venn diagram for this relation. And now you can see that all the element of this non-empty set x is associated with all the element of y, but here not unique association, because 7 is associated with 5 and 7 is also associated with 2. So here uniqueness property is not showing. That means this is not a special type of a relation. You can also observe for these examples and you can easily say that all the element of set x is associated with all the element of y, but here unique association is not possible. So this is also a relation but not a special type of relation. So we can say that this is a special type of relation. This is a relation but not a special type of relation, and this is also a relation but not a special type of a relation. So here we have only one special type of a relation. So we can say that this is a function, and mathematically function is represented by this symbol f such that x to y, or you can also write x to y, and f is a rule such that all the element of this non-empty set x is uniquely associated with this non-empty set y. So both are the representation for function. So basically this is the meaning of a function. Suppose you have a function y is equal to fx. It means y is a function of x. Here y is a dependent variable and x is the independent variable. Now suppose that graph of this function are given. Then can you tell me which curve is a function or not function? So it is a very simple. Suppose you have a curve and you want to identify which curve is a function or not function. So first of all, you have need to draw a perpendicular line on x-axis, because y is a function of x. That's why you have need to draw a perpendicular line on x-axis. And if the perpendicular line cuts this curve only one times, that means we can say that here is the unique association. That means this curve is a special type of relation. So we can say that this is a function. You can also check for this curve. So here is a perpendicular line and you can see that this perpendicular line is cut twice of this curve. That means here is a not unique association. So this is not a special type of a relation. That means this is a not a function. You can also check for these curves. If you draw any perpendicular line on x-axis, then you can see that this perpendicular line are cut twice of this curve. That means here is also not unique association. Means this curve is also not a special type of a relation. That means this is not a function. You can also check for this curve. If you draw any perpendicular line on x-axis, then you can see that this perpendicular line is cut only one time of these curves. That means here unique association, means this is a special type of relation. So we can say that this is a graph of a function. You can also check for this curve. If you draw any perpendicular line on x-axis, then this perpendicular line are cut only one time of these curves. That means element of x is uniquely associated with element of y. So this is also a function. Now let's move on our another important concept of a function, that is a domain, range and codomain. Suppose you have a function from set x to y such that x have a 3 element 1 2 3 and y have a 4 element a, b, c and d, and 1 is associated with a and 2 is associated with a and 3 is associated with b. So you can see that all the element of set x is uniquely associated with some element of set y. That means here is unique association. So we can say that this f is a function from set x to y. That means f such that x to y. So all the input value of x is called domain. So suppose that if you put all the value of x for x is equal to 1, 2 and 3, then you will get a and b only, because 1 and 2 both are associated with a and 3 is associated with b. So what is our input value? Here our input value is 1, 2 and 3. And what is our output value corresponding to all these input value? So our output value is a and b only. So this input value is called domain and this output value is called range, and collection of all the value of y are called codomain. Now suppose that our function is not in the form of Venn diagram, then how can find domain, range and codomain? So now let's see. Suppose that our function is y is equal to fx. So in this case domain is equal to all the input value of x. But suppose that this function is under the square root. So for in this case you have need to write its basic condition. So this function is only defined if our fx greater than is equal to 0. That means the value of a square root is always greater than is equal to 0, means a square root is always positive or 0. That's why this function is also defined if fx greater than is equal to 0. So by using this condition you can easily find the domain of this function. Suppose if algebraic functions are given in this form, that is fx divided by gx. So you know that denominator of any function is never be 0, because if denominator is equal to 0 then function is not defined. So in this case you can use this condition, denominator is equal to not 0. But suppose that our function is given in this form, a square root of fx divided by gx, then how you will find domain for this function? So simply you can write this condition, that is fx greater than is equal to 0 and gx not equal to 0. And suppose that the function is given in this form like fx plus gx, then what is the domain in this case? So in this case domain is intersection of these two conditions. Suppose here this function is only defined if fx greater than is equal to 0 and gx not is equal to 0. So in this case domain is equal to intersection of these two conditions. Suppose its domain is a d1 and domain of this function is equal to d2. So whole domain for this function is equal to intersection of these two domains. Now let's come to some basic example so that this concept will be clear. Suppose you have a function fx such that fx is equal to a square root of x square minus 3x plus 2. Then find the domain. So what is the condition for this function? So this function is defined if x square minus 3x plus 2 is greater than is equal to 0, and after solving this part this is equal to x minus 1 multiplied by x minus 2, and this is greater than is equal to 0. And if you find a sign scheme for this value, that is x is equal to 1 and x is equal to 2, so this is equal to minus infinity to plus infinity, 1 and 2, and you can see here the coefficient of x square is a positive, so this value is a negative, and here root is a single times repeated, so this value will be positive. And according to this condition, and you can see that minus infinity to 1 value is positive and 2 to infinity is a positive. So what is the domain for this function? Minus infinity to 1 union 2 to infinity. Now let's move on our another examples. Here function fx is equal to 1 divided by a square root of mod x minus x. So this function is only defined this part is greater than is equal to 0, because a square root is always greater than is equal to 0. But you can also see here this is in the denominator. So if we take this whole value is equal to 0, so our function is not defined. So for in this case we can apply only this condition, denominator is equal to only greater than 0. So mod x minus x is greater than 0 and mod x is greater than x. So mod x is x if x greater than 0 and mod x is minus x if x less than 0. So by using this condition, x greater than 0, x greater than x. So this is a false because any number is not greater than to itself. For example, 4 is greater than 4. This statement is completely false. So in this case, no any solution for this equation. Now let's apply our second condition. If x less than 0, so in this case, mod x is equal to minus x, and minus x is greater than x. Here minus x doesn't mean the number is a negative. Maybe it is a negative or positive. It's fully depend on the value of x. So we can write minus x greater than x. And you can also solve like this. If you take it on right side, so x plus x, and here is a only 0. So 0 greater than 2x. And we can also say that 2x less than 0, and if we multiply both sides 1 by 2, so this is equal to x less than 0, and in this case its domain is minus infinity to 0. And if you take intersection of these two domains, so what is the intersection of these two domains? Nothing. Suppose this is a phi and this is minus infinity to 0, so what is the intersection? This is only phi. So phi is the domain for this function. Now let's move on our another example. Fx is equal to sum of two functions. First function is this and our second function is this. So what is the domain of this function? I just solve this function in example number first. You can see that. So what is the domain in this case? Minus infinity to 1 and 2 to infinity. So this is the domain for this function. Now simply you have need to find the domain of this function. So if you solve this value, so this is equal to x square minus 3x minus 4. So here we can't to take is equal to sign because this function is in denominator part. So x square minus 3x minus 4 greater than 0, and this is equal to x square plus x minus 4x minus 4 greater than 0, and this is equal to x plus 1 multiplied by x minus 4, and this is equal to greater than 0, and this is equal to minus 1 and 4, and this is your plus infinity and this is your minus infinity. And here the coefficient of x square is positive, so this value is negative, and this is positive and this is positive, and I am taking only positive part because this function is greater than 0. So domain for this function in this case minus infinity to minus 1 union 4 to infinity, and final domain for this function is equal to intersection of these two domains. So what is the intersection of these two domains? And you can see for this condition 4 to plus infinity and minus 1 to minus infinity, and for this condition the value is minus infinity to 1. Here is equal to sign, so this is a closed circle, and another one is a 2 to infinity. So what is the common part in these two cases? So only this is a common part for these two conditions. So our final answer is a minus infinity to minus 1 union 4 to infinity. Here is a no close bracket because here only greater than sign. So this is also an open bracket and this is also an open bracket. So this is our final answer. So this is some basic example based on algebraic function. So basically in today's class I discussed the concept of Cartesian product, and with the help of Cartesian product I defined the concept of relation, and with the help of relation I explain about the concept of function. Then I discussed the graphical representation of function, and after that I solve few examples based on domain. So I hope you understand all the concept very well. So thank you and best of luck.